So first off, welcome everyone. I'd like to introduce our guest speakers today. This is Dr. Rankin and her student, Stephanie Young, and they're both from UVM. And let's give them a warm round of applause for being with us today.
Well, thank you. I'm delighted to be here, and we're delighted to be here, speaking for myself. And I have seen some of the excellent questions that you have already. I was joking a few minutes ago, but maybe not joking about these questions were so good. I have wondered if a lot of you have been taking college classes. Is that right? But anyhow, so let me just say a few words, and Stephanie can pop in when she wants to, about what I personally study, or what we study. I've been studying it longer than Stephanie, but we've been studying radio pulsars. And a lot of people have never heard of pulsars as a type of star, but they are larger than the sun in mass, but a lot smaller than the sun in size. A pulsar has, which we also call a neutron star, is about 6 miles or 10 kilometers in radius, but it has more mass than the sun. So if I reach over to pick up a cubic centimeter of star stuff from a pulsar, it would weigh, and I'm really not this strong, 1 billion metric tons. So they're incredibly dense, and they spin very rapidly. And for reasons that we've been working on, lots of people have been working on all over the world for a few decades now. We don't quite know how, but they send us radio waves like a lighthouse. So if you think about how our lighthouse works, blip, blip, blip as it goes around. Pulsars rotate on their axis. Think about them being spheres, and they rotate on their axis. They have canted magnetic fields, and above the magnetic polar caps, you can think about as the beams going out. And if you happen to be with us on the Earth here, when a pulsar beam comes by, if you have the right equipment, you can detect those beams, and they make a blip that's a little more complex than that, but basically it's a blip. And because this heavy star rotates so regularly, the blips are very accurate. They're actually very, very good clocks. But let me not talk about them, let me play them for you. A radio telescope is a radio, and we don't usually hook it up to a loudspeaker. We usually record it in computers and high-tech stuff. But we can hook it up to a radio and just listen to pulsar sounds. And so I just want you to keep in mind that what we're hearing here is the rotation of the stars.